The next topic is called as the Shanon Fano algorithm. Okay, so let's quickly go through the steps of this algorithm. Okay, so here what we try to do, we have certain set of symbols given, and we will be having certain amount of probabilities associated with each of the symbol given. Okay, so what we basically try to do, we split the given symbols fundamentally into two parts, okay, based on the probabilities. So once we have the certain amount of probability associated with that, what we try to do is after splitting that, right, we'll try to give the numbers to them, ones or zeros, and further we subdivide the each of the group into two groups and so on. It will keep on repeating, right? It is a iterative process of division among the groups. So let's look at the step-by-step procedure to do that. So the step number one is like this. So first we are supposed to arrange the probabilities in the non-increasing order. In the non-increasing order, that's the step number one. So we'll move on to the step number two, in which we try to make the groups depending upon the probabilities. Okay, so we have to split them into two sets such a way that when I take the sum of both the sets and I compare, they have to be approximately almost equal. Okay, it's not exactly required that you have to have very precisely equal. Okay, one is they are approximately equal, right? That's what we need to take care. Okay, so the probabilities group the probabilities into two sets. So how to do that? Such that the sum of the probabilities sum of the probabilities in both the groups both the groups sum is almost equal, right? So once the sum is equal, I have to assign zeros to the elements of the first group and one to the elements of second, right? So I'll try to assign ones and zeros to the various what you call ones and zeros will be assigned to the various elements of groups, right? So this will be my next step. So I'll write that is step number 3. I have to assign say bit 0, or okay, let's do the reverse. First let's give ones, because some of the times we may get confused how the code can start from 0. Okay, so bit 1 is assigned. So assign bit 1 to all the elements, of all the elements of, say, the group number 1, the first group, and assign the bit 0 to all the elements of group number 2. So after this, we'll repeat the steps until you have only one entry left, okay, or no further subdivision is possible. So okay, sorry. This is step number 4. So repeat step 2 and 3 by dividing the subgroups, okay, until no further subdivision, is possible. So until there, we should repeat this step. Okay, let us go for a problem to understand this. So the symbols are given in the following fashion: x1, x2, x3, x4, x5, and x6. Let's write down the probabilities also in the same fashion. Okay, probabilities are given 0 0.4, 0 0.2, 0 0.2, 0 0.1, 0 0.07, 0 0.03. Okay, all right. So this is the given, what you call, given details about the various symbols generated and their probability. So step number 1 says that you have to write them in the non-increasing order. So they can be equal, but it should not increase. So it should be decreasing. So as you can see here, right, it's already given in the non-increasing order. So we don't have to do step 1 here. Directly we'll go to the step number 2. Okay. All right. So what we do first, let us try to write them down. So let me write the x and the probabilities in the form of columns. That will help me in identifying the code. Okay. So what I do, I'll write them. So this is x1, x2, x3, x4, x5, x6. Right. I'll also write down the probabilities side by. So this is 0 0.4, 0 0.2, 0.2, 0.1, 0.07, and 0.03. Okay, right. So step 1 is already completed. Let's directly move to the step number 2. So in the step number 2, I have to split them into two groups, such a way that when I add the individual probabilities or probabilities of each group should be same. So for example, let's try to make a group like this. How much this, if I make this as a group, the probability of this sum is nothing but 0.6, correct? So I'll check this. So this is 0.1 plus 0.1, zero point 0.2 plus zero point 0.2, this is zero point 0.4. So you see I have zero point 0.6 and zero point 0.4, one possibility. Let me try to do another grouping here. Only first one I'll make a group, that is 0 0.4, and all the others if I club I'll get 0 0.6. These are the only two options. Correct? What we are expecting, we are I'll repeat. So far we simply splitted the two groups. Okay, first group has a probability 0.6, second group has the probability 0.4. Right, that's the almost equal probability that we can get in this case. Now for the first group elements, assign the value as 1, code as 1. For the second group, assign the codes to be 0. Now, in the next step, we are supposed to further subdivide the groups, right, in a very similar fashion. So, first group has 0 0.4 and 0 0.2. I will divide them in the same fashion. So, 0 0.4 is one group, 0 0.2 is the other group, right? Only two possibilities. This is one group, this is other group. Assign 1 to the first group, 0 to the second group. Whereas in the second set of the original group, right, x3 is 0 0.2. The probabilities of x4 plus x5 plus x6 is also zero point 0.2. So they are equal group. So I can make one group here 0 0.2 and one more group 0 0.1, 0 0.07 and 0 0.03. Right? So these three belong to the second group of this. So you again apply the same thing. 1 for them, 0 for this. Is it okay? Now you see the first, second and the third entries we have made, they cannot be further subdivided. So there is no question of dividing them, but the last group can be further divided. Correct? So let me try to write this way. So 0 0.1 is one entry, one group. So 0 0.07 and 0 0.03, it's the second group. Correct? So this is 1, these two have zeros. Now once again I can split the 0 0.07 as one group and the 0 0.03 as a second group. So this is sorry, the first entry we'll keep it as 1 and the second one we'll make it as 0. Okay, so these are the possible. Now how to read the code? The code for x1, right? Code for x1 is 1 1. Okay, yes, there are conventions, like you follow same thing throughout, right? Either you can write zeros for the first group and 1 for the second group. Absolutely fine. Okay, so as we can see here, the x1 gets the code 1 1. Okay, so then x2 gets a code 1 0, x3 gets a 0 1, and so on. Okay, let me quickly write the result. Okay, so the results are like this. We are trying to write the codes corresponding to each of the uh, generated symbol. Okay, you can make another table if required. So the symbols and the code word. So we have x1, that is 1 1. Okay, x2 is 1 0. Then we have x3, that is a 0 1. Okay, later we had x4, that is 0 0 1. Then x5, that is 0 0 0 1, and x6 gets code word as 0 0 0 0. Okay, it's a pretty straightforward method of computation of the probabilities and using the probabilities for the calculation of the code. Okay, all right, let's go further. This is the next question. So symbol S has the following options. A, B, C, D, E, F. And the probabilities are as follows: 0 0.1, 0 0.15, 0 0.25, 0 0.35, 0 0.08, and 0.07. Okay, all right. Please try to solve this. Yeah, so we get the following codes. Okay, D 11 10, B is 1. Okay, all right. All right, so that's the answer we are expecting. All right, let's move further. Now I add another question to the main question. That is, we need to find out the efficiency of the code as well as the redundancy of the code. Okay, right. So the question pretty much remains same. So we have the S given by S1, S2, S3, 4, 5, 6, 7, 8. And the probabilities are defined in the same way, like 27 by 64, 9 by 64, 9 by 64, 9 by 64, 3 by 64, 1, 2, 3, 4, 5, 3 by 64, 3 by 64, comma, 1 by 64. Okay, first part, normally you do get the codes, and then we'll proceed to the second half of the question where we need to find the efficiency of this code. Okay, so these are the uh, codes that we can obtain: S1, 1, 1. All right, then S2, 1, 0, S3, 0, 1, S4, S4 is no, S3, S4 both are same. Can you check? S4 is 0, 0. Okay, all right. Then I think length will increase. Length will increase for S3, S4. Please verify once. Hmm. Okay, the remaining six symbols you are going to split as 2 and this, right? Ah, okay. Right, right, right. Okay, correct. So you have 0, 1, 0, 1 repeating. Then it will be divided into zeros and ones. So 0, 1, 0, 1 is fine. I think you get a 1 here and 0 here. Just check. Okay, 0, 1, 0, 0, right? 0, 1, 1 and 0, 1, 0. Okay. Okay, then right, 0, 0, 1, 1, 0, 0, 0. Okay, right, S6. All right, we'll go ahead. Then S7, 0 0 0 1. Okay, 8 0 0 0 0. All right, now let us mark the length of each symbol, that is Li. Okay, this is first is 2 2 3 3 and all fours, right? Right. So anyway, we have the probabilities with us. So directly I need to calculate the the average length. Okay, how do you calculate the average length now? So that is capital L is equal to summation of over all the values. It is Pi into Li. Correct? So probability is 27 by 64. That is multiplied by 2, first number, plus the second one has a probability 9 by 64 into 2, right? Plus 9 by 64 into 3, right? Then plus 9 by 64 into, that's also 3. Okay, plus after 9 by 64 we have 3 by 64 into 2 2 3 3 is over, then this is 4. Okay, plus 3 by 64 into 4 plus 3 by 64 into 4, then this is plus 1 by 64 into 4. So that's going to give you the average length. So this answer is 2.48. Normally this is the length in bits. So many bits are bits of information. Then calculate h of s as per the equation. This is sum of pi into log to the base 2 1 divided by pi. So each probability will write that. So that is 27 by 64 log to the base 2 64 by 27. Then I can see that the 9 by 64 is repeated 3 times. 3 times 9 by 64 times log to the base 2 64 by 9 plus 3 more times we have 3 by 64 log to the base 2 64 divided by 3. So after that we have one more last term remaining, that is 1 by 64 times log to the base 2 64 by 1.